Let's break down the working mechanism of SSL TLS step by step. Let's suppose we have a client at one end and an Nginx server at the other end. The whole point is that the client wants to communicate with the Nginx server. The easiest way is not to apply any encryption method. The client will make a GET request and the server will return a response. The problem in this architecture is that any middleman can snip the communication. Let's say we have a hacker who can easily snip the request and response. This is called a man-in-the-middle attack. So our goal is to secure the communication between the client and the server. Now the interesting part begins. How do we encrypt the communication? Suppose we have data such as a text or a password. For this, we need a key to encrypt the data. The same key is used to both encrypt and decrypt the data, which is called a symmetric key. Let's suppose the client has the key which it uses to encrypt the data. The data is then sent over a GET request to the server. However, the problem is that the Nginx server can't read the data because the key is not available on the server side. The server cannot decrypt the data because the key is only with the client. At this point, the key must also be transferred to the server. But if we try to transfer the key freely over the network, a hacker can intercept it and keep a copy. So, if we communicate in the future, the hacker can also decrypt the messages. So the condition is that both the client and the server must have the key, but the hacker must not have access to it. In this scenario, we use another type of encryption called the asymmetric encryption. In asymmetric encryption, we have two types of keys, a public key and a private key. The public key can encrypt the data and only the private key can decrypt it. In this case, we have data that need to be transferred from the client to the server. First, the server has two keys, a public key and a private key. The server provides its public key to the client. Even if a hacker gets a copy of the server's public key, it is okay. Then the client generates its own symmetric key and encrypts it using the server's public key. Now this encrypted symmetric key is sent to the server. Even if a hacker intercepts it, they cannot decrypt it. The encrypted key can only be decrypted using the server's private key. The server then decrypts it and keeps a copy of the symmetric key. Now both the client and the server have the same symmetric key and secure communication can begin. The hacker cannot decrypt the data because they do not have the symmetric key.